Welcome back everybody to episode 4 in our programming subseries. So I'm going to devote one video to each of the primitive data types because they're important, because they're the building blocks to every programming language. So we're going to start with the char, char, however you want to call it. So this stands for character, and characters in programming are used to store human readable and interpretable symbols into a binary format. So back in the day, the American National Standard Association came up with this ASCII standard, which basically took every character in the English language and gave it a number. So that's what the ASCII chart is, and currently there are 256 symbols in the ASCII chart, but back in the day there were only 128 because they needed a security bit for certain purposes. I don't know why, but nowadays they use 8 bits to represent the letters, so they have 256 possible letters. As computing got more popular around the world though and drifted away from just being an English concept, we had to be able to translate other symbols into binary, so stuff like hieroglyphics, or Chinese, other languages. So that's where the Unicode Standard comes in. So ASCII code is a subset of the Unicode Standard. So let's have a look at those. Okay, here we are. Here's the ASCII table. So we start at 0, and like I said, back in the day they used 7 bits, so they only had 128 possibilities, and this covered everything they needed, so all the letters, all the numbers, and even some commands. But then we were able to get an 8th bit, and that added what's known as the extended ASCII table. So this gave us the values 128 through 255, so quite a few more. But the thing with the extended ASCII table is that there are multiple versions of it, where with the old ASCII table, which only has 128 values, this is the only version of this table, whereas the extended one has multiple versions. So here is the Unicode table. As we can see, we said the ASCII table is a subset, and you can see the values 0 through 256 are going to be the same, so you can recognize some of these symbols. We have all the alphabet, all the numbers, and even some commands. But then when we get past those decimal numbers, we get into other characters that aren't a derivative of the English language. So if we just scroll down here, we have a bunch of like Greek letters, I think they are, and then this goes all the way to like I think this is Arabic, and then it even includes emojis. So that's how extensive the Unicode is. Okay, so in the Unicode there are currently 144,000 symbols included. So to represent all of these symbols, we would need each character variable to have 17 bits of memory. But not all programming languages are built equal. So for example, Java uses 2 bytes, so 16 bits to represent their characters. So this would give them a total of 65,535 possible characters, or 36 characters because we start at 0. And then in a language like C uses 1 byte for its characters, so it could only represent 256 characters. So there's a big difference there. Okay, so how do we actually convert the character into a binary format, 0s and 1s? Well, we use the standards like we talked about. We use the charts, so we find the letter and then see what decimal value it has. Then we convert that decimal value into binary, and then we have some options. We can leave it in the ASCII format, or we can convert it into Unicode. And most programming languages today use Unicode because it's a lot more extensive, like we talked about. And there are 3 ways to convert into Unicode. Because we have to use more bits, we can convert using 8-bit chunks, we can convert using 16-bit chunks, or 32-bit chunks. So we started by using 32-bit chunks when Unicode first came out, and this was a problem because when you had a letter like A, capital A, which is value 65, or this binary number, you can see that we really only need 7 bits for this letter. So we should only be using 8 bits, the 8-bit standard, but back in the day we only had the UTF-8 or 32-bit, so we had to use 32 bits, and we had all these zeros that we really didn't need. So that's why we came up with UTF-16 and UTF-8. And then another advantage, other than just saving space with UTF-8, is that since ASCII code is an 8-bit standard, so it can represent 256 values, and so it can 8 bits. Since we're chunking the Unicode into 8 bits, the UTF-8 version of Unicode is going to be the same exact as the ASCII code. So in ASCII code, capital letter A would be this 01000001, and in Unicode UTF-8 it would be 01000001, so the same thing. Okay, so one other advantage to using UTF-8 is that, well, like what I just said, ASCII is readable when you're using Unicode. So if you're trying to read in Unicode using one of these standards, UTF-8 or UTF-16, then if you're using UTF-8, you'll be able to read the ASCII because they're chunked into 8 bits per letter. So we'll just go through this really quickly. We have some Unicode and ASCII in the same file, and we're using Unicode to read it. And let's say we're using UTF-8, that version of Unicode. So it would split this into 8 chunks, and since this is Unicode, it would read this as the letter N. I don't know if these are the actual letters, but then we get to what's supposed to be ASCII code, and it chunks it into 8 bits. So it reads the letter 0, which is, in ASCII, it's the letter 0, and Unicode, it's the letter 0. I'm saying 0, it's O. Wow. Okay, anyway, if we were to use UTF-16, it would read the first 16 bits in Unicode properly, but then when it got to the ASCII code, since there's only 8 bits in ASCII code and it's looking for 16, it'd be like, what the heck is this? In file 2, we have 16 bits for both Unicode and ASCII. So if we used UTF-8, it would read the Unicode properly, because UTF is a Unicode transmission format or translation format. That's what this stands for. So it'd read the Unicode properly, and then you get to the ASCII and read it properly because it's splitting it into 8 chunks, 8-bit chunks. But if we were using the UTF-16, it'd read the Unicode properly, but then it'd get to what's supposed to be ASCII, and it'd split it into, it would just see all 16 bits and try to see it as 1 letter instead of 2 letters. So it'd give you a wrong answer. That's another advantage of UTF-8. Okay, I have 2 programs to exemplify the char data type. So here we're just asking the user for a letter or some letters, and this is just showing you that a character can only store 1 letter. So it's asking for some characters down here in the console, so I'll just input some characters, and you can see it's going to say the character. So our variable is just storing 1 of those symbols, just the first one that we gave it, so P. If I do this again, now it's going to be A. So that's just showing that a character can only store one symbol at a time. Now, to contradict myself somewhat, we have these things called escape sequences. So escape sequences are just backslashes with a letter, a certain letter. There are multiple escape sequences in any given programming language, and these are just shorthand ways of telling the computer how to do special commands, like go to a new line or insert a tab, something like that. Okay, so here is another program. This program is simply taking a value from the Unicode chart and printing out what value or what symbol it is. So if we run this, this will give us a special symbol. So an E, capital E with a little accent mark. And if we look on the Unicode chart, that was value, let's see, value 200. So we'll look for 200 here. Okay, so here is the value 200. You can see if I hover, it says decimal value 200, and it's the exact same symbol that printed in our program. And it printed this symbol because the Java language uses UTF-8 standard or 16 standard. It uses UTF-16 standard, and that's why we're looking in the Unicode for this symbol. Okay, one last thing to mention before I go is something with variables. So you can see I declare a variable here, and this is what's called declaring a variable. You're basically saying what type it is and then the name that you want to give it. But in this program, I'm doing what's called initializing the variable, so I'm giving it a value, whereas in this previous program, I just declared it and I didn't initialize it. So that's one discrepancy and one term that you should know, initializing a variable.